One of the main things that I want you to learn in this video is that enteral feeding problems are solution mixing problems. Enteral feedings is another word for tube feedings, but enteral is a little bit broader. It does not have to be a tube feeding. When we're administering a tube feeding or any enteral feeding, we are going to give our patient both water and a nutritional supplement. So for this video, our goal is to create 300 milliliters of a 1/3 strength Ensure mixture. So we want to keep that goal in mind as we work through the idea of mixing two substances to create, in this case, the perfect enteral feeding. And so we're going to be looking at it as a solution mixing problem. So here's my friend Curious George, and he's mixing paint. Now, of course, keep in mind our goal is this 1/3 strength. So we're going to use red and white because we know they'll create pink, and we're going to want a 1/3 strength pink instead of 1/3 strength Ensure. So let's add some Ensure or some red. And it's pure red. Put some on a balloon there. Pure red. Okay, that's like pure Ensure, not diluted at all. So, but we want 1/3 strength pink. So we're going to add a squirt of pink, or excuse me, a squirt of white. We mix. We saw it got a little bit lighter. Go over here, paint a different balloon. Oh, it's very subtle, but it's a little bit lighter. Well, what strength pink is this in the bowl? Well, we put in 1 squirt of red, 1 squirt of white, so half of it is red. So it would be 50% or half strength pink. But we want 1/3 strength pink. So we're going to add some more white to dilute it further. Now, in our bowl, we have 3 squirts of paint. 1 squirt of red, 2 squirts of white. So 1/3 of this is red, and so we've made a 1/3 strength pink, and we paint a balloon. Ah, perfect pink, 1/3 strength. So let's take this concept of our little friend Curious George mixing paint. He created 1/3 strength pink, which meant 1 out of the 3 squirts was red. So there he is, Curious George. He had 100% red in here, full strength, and then the white, there's really no red, so 0% red in the white. And we created perfect pink by using 1 squirt of red, 2 squirts of white, and we had 1/3 strength, or 33.3%. So we want to pull this idea of Curious George, the full strength red, the white, which is 0% red, to creating the 1/3 strength red, which was our perfect pink. So there was our goal. We want 300 milliliters. We want 1/3 strength. And so in real life, what we're mixing is water and our formula. In this problem, we are creating 1/3 strength Ensure. So our formula or nutritional supplement is Ensure, and then we're going to dilute it with water. So our question is, how much Ensure and how much water do we need to prepare this ordered amount? And we know that we're going to be mixing them. So here I have a beaker. I can see my 300 milliliter mark. I'm going to be pouring in some Ensure, and then I'm going to be pouring in water to create this perfect mixture, this 1/3 strength Ensure at exactly 300 milliliters. So coming back to Curious George and using the idea of Ensure, we'll let our red be our Ensure, and it is 100% Ensure, all nutritional, not diluted at all. We'll let our white be the water. The water contained no Ensure, no nutritional value. And then our pink is our 33.3%, our 1/3 strength, and we know that in our pink we want exactly 300 milliliters. So let's take a look at the math. We have our concept of the red being Ensure, the white being water with no Ensure mixed together, have the same idea here. So 100% Ensure, 0% Ensure to make our perfect mix. We're going to need a variable. So we'll let X be the milliliters of Ensure. It's the first question asked, how much Ensure? How would we measure a liquid? We'd measure it in milliliters. Now, the water we'll get by taking the total amount, 300, and subtracting out the Ensure, because whatever's not Ensure is water. And I can tell if I put a bit of Ensure, the rest of it would be water to create my perfect mix. We need our percents as decimals. So 100% would be 1.0 or just 1. 33 and a third percent is 0.3 repeating. Now, we have a concept equation. We know that we're taking Ensure, we're adding water, and we're coming up with a 33.3% mixture. And so putting that into math, the Ensure, I want to take the strength, which is 100% as a decimal, times the volume, which is X. The water, I want to take the strength, which is no Ensure, so 0 strength, and the amount is this expression, 300 minus X, make sure I have my parentheses. I want to take my percent, which was really 33 and a third, so 0.3333 times the amount of the mixture, 300. So I do some simplifying to do the math. 1x is just x. 0 times anything is 0, so this entire piece here in the middle cancels, and that equals 0.333 times 300. I type that on my calculator, and I have 100 milliliters of Ensure. So I've answered a question. How much Ensure? 100 milliliters. Next, I want to figure out how much water, and I have a formula right here to do that. So I take 300, and I subtract out 100, and I have 200 milliliters of water. So as long as I put in 100 milliliters of Ensure, right to the 100 line, 200 milliliters of water takes me up to the 300 line, I've got the perfect 1/3 strength mixture. So our textbook, our workbook, takes this whole process and simplifies it. So as long as we let X be our milliliters of Ensure, we can go directly to this line of the equation and say that X is the strength that we want times the total volume. Because that's how this formula is simplified, because we're always adding water. So we always have a 0 here in the middle to cancel out this middle term. And then it gives us a formula for the water too, and it tells us take the total and subtract out the whatever formula it is, the nutritional supplement, and you have the water. And so when we have an enteral feeding problem, we have a solution mixing problem, but our workbook gives us a shortcut in giving us these two little formulas that take us directly to the answer.